This is Chapter 6 on Fats from the 4th edition of Nutrition for Sport and Exercise. The first part of this chapter is review from your introductory nutrition classes. It includes classifying fats according to their chemical composition, as well as describing the digestion, absorption, transportation, and storage of fat. The metabolism of fat is covered more in depth in this chapter, which includes the mobilization, transportation, uptake, activation, translocation, and oxidation, as well as ketosis and the effect that it may have on training. In this chapter, you'll learn how the body uses fat to fuel exercise. You'll learn the fat recommendations for athletes and how to calculate the amount of fat needed daily, how to identify sources of dietary fat and assess an athlete's dietary fat intake, as well as evaluate dietary supplements related to fat metabolism. Fat is the primary source of energy at rest and during low-intensity exercise, such as endurance exercise. And remember that the better trained you are and the more you exercise, the more efficient you become at using fat for fuel during both rest and during activity. Fat's the most concentrated source of energy at 9 kilocalories per gram versus 4 kilocalories per gram for protein and carbohydrate. Certain fats are associated with chronic diseases, notably cardiovascular disease, but also for some types of cancer. And fat is also known to be inflammatory, so it can lead to chronic inflammation or diseases associated with chronic inflammation. It's important to know the amounts and types of dietary fats in foods, both for athletic training and performance, as well as prevention of disease. Fatty acids are chains of carbon and hydrogen with a carboxyl group at one end. Fatty acid chain lengths are even, so there's an even number of carbons. A saturated fatty acid does not contain a double bond. It's completely saturated with hydrogen. If a double bond is present, it may be one of two formations, and those two formations are either cis, meaning the hydrogens are on the same side, or trans, where the hydrogens are across, and we'll see a diagram of that in a minute. Hydrogenation is the process of making liquid oils more solid. So it's the process of adding hydrogen under pressure to eliminate some of the double bonds and make the fat more solid. And this process is known for creating some of the unnatural trans fatty acids, which are not considered healthy. They act like saturated fat in the body in terms of raising the bad type of cholesterol and potentially lowering the good type of cholesterol. Oleic acid is an 18-carbon fat that's found in plant and animal fats. It's a monounsaturated fat having one double bond, and the hydrogens are on the same side, so it's a cis fatty acid. And in chemistry, often to simplify drawing of diagrams, at each point is considered where there's a carbon. So each of these points has a carbon, and each of these is one single bond, not a double bond. If it's a double bond, it would show two lines. And so again, this is 18 carbons long, although not all the carbons are shown in this diagram. And here's the carboxyl group at one of the ends of the fatty acid. Fatty acids vary according to their chain length, and you can see these three fatty acids have varying lengths of the carbon chain, and they vary based on their degree of saturation. This fatty acid is palmitic acid, which is completely saturated with hydrogen. Oleic acid, as we saw, has one double bond, so it's monounsaturated. So it's not completely saturated with hydrogen. It has one double bond where there's missing two hydrogen atoms. Linoleic acid is a polyunsaturated fatty acid, which a polyunsaturated fatty acid has two or more double bonds or points of unsaturation. And linoleic acid is one of your essential fatty acids. The other essential fatty acid is linolenic. Vegetable oils are an excellent source of both mono and polyunsaturated fatty acids. Saturated fatty acids are found in more solid fats such as butter or margarine. And oils are recommended based on the predominant type of fatty acids, such as, we know monounsaturated fatty acid is very healthy in terms of our lipid profile. It can help to lower the bad type of cholesterol, or LDL, as well as raise the good type of cholesterol, your HDL. So olive oil, canola oil, avocado oil are all very high in monounsaturated fatty acids. So we tend to often recommend these for your health. And olive and canola also have the benefit of having omega-3 fatty acids in them. This slide shows two monounsaturated fatty acids. One is oleic acid, and this is a cis fatty acid with hydrogens on the same side. Oleic acid is also a monounsaturated fatty acid, but this is a trans fatty acid with hydrogens on the opposite sides of the double bond. The cis form allows the fatty acid to bend, and the hydrogen groups are located on the same side of the double bond. In the trans form, the fatty acid is straight, and the hydrogen groups are on the opposite side of the double bond. This fatty acid is eicosapentaenoic acid, or EPA, which is one of your fish oils. And it is an omega-3 fatty acid. And the name omega-3 comes from where the double bond is, the closest double bond is in relation to the end, or the omega carbon, which is on this end. It's the methyl end. So here's 1 carbon, 2 carbons, 3 carbons. So this double bond is located 3 carbons from the end, or the omega carbon, and therefore it's called an omega-3 fatty acid. Linoleic acid, which is also a polyunsaturated fatty acid. Notice that this has 2 double bonds. This has more than 2 double bonds. This polyunsaturated fatty acid, though, is an omega-6 fatty acid because the double bond is 6 carbons from the end, or omega carbon. Here's 1 carbon, 2, 3, 4, 5, 6. So the double bond closest to the end carbon is 6 carbons away. So that is an omega-6 fatty acid. And oleic acid, which is a monounsaturated fatty acid, is an omega-9 fatty acid because the double bond is 9 carbons from the end carbon. And oleic, as we mentioned, is found primarily in olive oil, and it's a, as we said, a cis and monounsaturated fatty acid. Most fats in food, as well as the fat that's you store as body fat, are in the form of triglycerides. And a triglyceride is a compound that the backbone is a 3-carbon compound called glycerol. And glycerol has a fatty acid attached to each carbon. And these fatty acids are often all different from one another. They can be saturated, monounsaturated, and polyunsaturated, all in one triglyceride. I mentioned that fats are often recommended based on their predominant type of fatty acid. And as you can see here, foods contain all 3 types of fatty acids: saturated, which is in blue, monounsaturated, which is in red, and polyunsaturated, which is in green. If we look over here at olive oil, we recommend olive oil often because it's highly monounsaturated, which is a very desirable type of fatty acid to have in our food because of the effect it has on our blood lipid levels. It can help to lower the LDL and raise HDL. It still has a little bit of saturated fat as well as some polyunsaturated fat. And in terms of the polyunsaturated fat, it has a little bit of the omega-3s in here in terms of linolenic acid, which is one of your essential fatty acids. Canola oil is also highly monounsaturated, with a little bit of saturated fat and a little bit more of the polyunsaturated fat. And within the polyunsaturated fatty acids is contained some of the omega-3s as the linolenic, which is, again, one of your essential fatty acids. So these two types of oils tend to be very desirable. Olive oil is really good for cooking, stir frying, and canola oil is better than olive oil for something like baking. Looking over here at the animal fats, it's often recommended that we have chicken versus beef. And if you look at chicken fat, it has monounsaturated and some saturated and poly. If you look over at beef, it has more saturated fat than the chicken. It still has some monounsaturated and a little bit of poly. And then pork is kind of in the middle. So there are some leaner cuts of pork, but overall it does have a significant amount of saturated fat. Now, coconut oil has a large amount of saturated fat, so you might wonder why people are recommending and consuming coconut oil. And coconut oil has a type of fatty acid that is a shorter chain than some of these other fatty acids that are saturated. It's 8 to 10 or 8 to 12 carbons versus the 18 carbon or longer length of these saturated fatty acids. So they're called medium chain triglycerides within the coconut oil. And that they tend to be a little bit healthier, although the jury's still out as to whether or not they really truly do lower LDL cholesterol. And so it's just a recommendation that we still use that in moderation. You don't want to go overboard and start using coconut oil in everything because, again, there's conflicting research as to the true health benefits of coconut oil. This slide is to test your knowledge of omega-3 fatty acids, sterols, and phospholipids by matching the term on the left with the phrase on the right. Omega-3 fatty acids are your ALA or alpha-linolenic acid, DHA, and EPA. Alpha-linolenic acid is found in your plant sources such as flaxseed, nuts such as walnuts, dark green leafy vegetables, soy, canola oil, and your DHA and EPA are found in your fish oils. Alpha-linolenic acid can be converted into DHA and EPA in the body, but it's not a very efficient conversion. And therefore, it's recommended that we consume fish at least twice a week to get our recommended omega-3 fatty acids. Or you can take fish oil supplements, and it's recommended 1,000 milligrams a day of EPA and DHA. Alpha-linolenic acid is one of the essential fatty acids. The other is linoleic, which is an omega-6 fatty acid. Triglycerides make up 95% of the fat found in food as well as in body fat, as we mentioned. Sterols they have a core structure of the fat, which is made up of 4 rings. And then it has a side chain attached to make it the most common sterol in food, which is cholesterol. A steroid is a compound that has a 4-ringed nucleus, what we call a 4-ring structure. And when a certain side chain is added to it, it can become a sterol such as cholesterol, or it could become a steroid such as cortisol, or it could become vitamin D, or your sex hormones such as estrogen or testosterone. But the basic structure in all the steroids is this 4-ring nucleus, which we'll see within a few slides. Phospholipids they have a glycerol backbone such as a triglyceride, so that 3-carbon glycerol backbone, and with 2 fatty acids attached, and then they contain a phosphate group. And they're a very important component of cell membranes, just as your omega-3 fatty acids are and cholesterol is. All of these are very important components of cell membranes. And note that cholesterol is found only in animal foods. So if you ever buy a product such as, let's say, chips or peanut butter, and the label says no cholesterol, well, the food never had cholesterol in it to begin with, because cholesterol is found only in animal products. Fatty acids not incorporated into lipoproteins, which are called chylomicrons, are released into the bloodstream. Blood lipid levels are highest 3 hours after fat consumption. The triglyceride portion of chylomicrons can be absorbed by muscle and adipose cells. The enzyme lipoprotein lipase, and you know it's an enzyme because it ends in ASE, and it acts on lipids. So lipases are enzyme that acts on lipids, stimulates the release of fatty acids from triglyceride, allowing cells to rapidly absorb them. Adipose tissue or adipocytes are fat cells and are the main storage sites of fat. Lipoprotein lipase activity, meaning the fatty acids are released from triglycerides so they can be absorbed by fat or muscle cells, is stimulated by the hormone insulin. Fat storage in muscle occurs primarily in muscle that is highly aerobic. And this is in muscle such as heart or myocardial muscle and slow twitch, or what we call type 1 muscle fibers. And slow twitch tend to be found in individuals that have great endurance. And fast twitch or type 2 are more muscle fibers that are recruited for jumping, sprinting, so anaerobic type activities. But the type 1 or the slow twitch are more highly aerobic. And advantages of the storage of fat is that it's a very energy dense nutrient. It has 9 kilocalories per gram, or twice that of carbohydrate or protein, and it's anhydrous, meaning it does not have water associated with it. So it makes it even more efficient storage form of energy on a per unit weight basis. This slide is of the mobilization and transportation of stored triglyceride. And this is an adipocyte or a fat cell, and you can see the nucleus of the cell over here, and then this is the triglyceride portion that's stored within that fat cell. Within an adipocyte, there's an enzyme, hormone-sensitive lipase, that will break down a stored triglyceride into glycerol, which is that 3-carbon backbone, and 3 fatty acids, which diffuse into capillary circulation. The fatty acids are bound to albumin for transport. Albumin is a protein. The process is initiated with the stimulation of an androgenic receptor, such as epinephrine. So these androgenic receptors on the cell membrane can be activated by stress hormones, not only like epinephrine, but also norepinephrine. And epinephrine is also known as adrenaline. And once in the blood, fatty acids can be distributed to other tissues throughout the body. A key element for the utilization of fat for fuel is the delivery of adequate amounts of fatty acids to the tissue. This slide is of the mitochondrial transfer of fatty acyl-CoA. So after the mobilization, circulation, and uptake into the cells, the fatty acids must go through an activation step before being transported into the mitochondria. So you can see this diagram is the outer mitochondrial membrane, and then here is the inner mitochondrial matrix. So this process takes place in the outer mitochondrial membrane prior to the translocation of the fatty acid into the mitochondrial matrix. And you're not responsible for knowing all this detail. You just need to know the importance of the mitochondrial transfer of fatty acyl-CoA. Because fatty acids are ultimately metabolized inside mitochondria, translocating the fatty acids into the mitochondria is a critical and potentially limiting step. And note that cells that have a large number of well-developed mitochondria, such as slow twitch muscle fibers, we mentioned those are the type 1 fibers, those have an increased capacity to take up and metabolize fat. Athletes with a genetic disposition for a greater number of slow twitch muscle fibers have an increased ability to metabolize fat. Regular endurance exercise training also results in an increase in the number and size of mitochondria in the trained muscles, and this further enhances an athlete's ability to metabolize fat. Fatty acids are primarily oxidized via oxidative phosphorylation, such as we covered in the first couple chapters of the text. Sometimes acetyl-CoA may be catabolized or broken down to produce ketone bodies, and this is actually a normal metabolic pathway. Such as after an overnight fast, ketones supply 2 to 6% of the body's total energy needs. It's not normal, however, if blood ketones accumulate to an abnormally high amount or there's ketones present in the urine. That would be abnormal. And remember that ketones can supply energy to the body just like glucose. However, glucose is still needed for the brain and the nervous system. When fatty acid oxidation is accelerated, ketone production will increase. This can happen when carbohydrate intake is low or during periods of starvation. Ketoacidosis may result in someone with diabetes. Ketoacidosis rarely will occur in someone who's not diabetic, even if they're in ketosis. And ketoacidosis is actually a very dangerous condition in diabetics that can lead to coma or death. So it's really important to differentiate between a diabetic that's in ketosis that can go into ketoacidosis and a non-diabetic who's in ketosis. Low glycogen or carbohydrate stores result from an athlete in a state of ketosis, and therefore it's unlikely to really benefit their performance. Now, there are some researchers out there that promote the lower carb diets for athletes. However, the majority of experts in the field say there may be some training benefits, but it definitely does not benefit performance. 3 of the ketone bodies that are made that will put someone into ketosis are acetoacetate, beta-hydroxybutyrate, and acetone. Ketone bodies are produced as acetyl-CoA accumulates. It's important to remember that training enhances the utilization of fat for fuel during both rest and during exercise. Advantages of using fat during exercise include that it's very abundant in our food supply, it's very energy dense, having the 9 kilocalories per gram. Every individual, no matter how lean, has a substantial amount of storage of triglycerides in their adipose tissue. And the metabolism of fat leads to a large amount of ATP, about 129 ATP versus 36, 38 ATP from carbohydrate. Disadvantages of using fat for fuel during exercise is it takes some time to transport and metabolize, and it also requires the utilization of oxygen. A little bit of review from the first couple chapters. Indirect calorimetry and the respiratory exchange ratio, or RER, determine fuel utilization during aerobic exercise. Carbohydrate requires a use of oxygen in an equal amount to the carbon dioxide produced. This means the RER for carbohydrate will be close to 1.0. The oxidation of fat requires a greater consumption of oxygen compared to carbon dioxide produced. This means the RER is closer to 0.7 for fat. Absolute energy expenditure is always expressed as kilocalories per minute. This table shows the heart rate, respiratory exchange ratio, and relative and absolute energy expenditure from fat and carbohydrate at rest and at 4 different running paces for a 49-year-old male marathon runner. So you can see at rest, The respiratory exchange ratio is closer to 0.7, where there's higher utilization of fat for fuel. And as the pace increases, there's an increased amount of carbohydrate used for fuel. And if you look over to the absolute energy expenditure, you can see the difference in the amount of fat utilization in kilocalories per minute versus carbohydrate at rest. And then down near the bottom at a faster pace, the amount of fat utilization is much less than the carbohydrate utilized. In this slide, you are to choose the incorrect answer. If we look at A, as VO2 max increases, the percent of energy from carbohydrate metabolism will increase. And as VO2 max increases, the percentage of fat metabolism decreases. And as VO2 max increases, exercise intensity will also increase. So A, B, and C are correct, and D is incorrect. So as VO2 max increases, exercise intensity is increasing, meaning the percentage of energy from carbohydrate metabolism is increasing. And when carbohydrates are being utilized, the amount of oxygen produced and CO2 used is close to equal, meaning the RER is close to 1. So here the RER would not be decreasing. This slide shows the absolute fat and carbohydrate oxidation. Absolute energy expenditure from carbohydrate oxidation increases as exercise intensity increases and is higher than fat oxidation at all running paces. Absolute fat oxidation increases as the energy intensity increases from a running speed of about 6.3 to 6.7 miles per hour, then declines as the exercise intensity continues to decrease. But note that the better trained the athlete, the more efficient they can be utilizing fat for fuel, even at higher intensities. So let's say this individual utilized fat at this level. Well, an individual who is better trained might be able to utilize fat at a higher level. And that's one of the beneficial adaptations of training, that you become more efficient at using fat for fuel and therefore can spare your carbohydrate or spare your muscle glycogen. And that allows you to go longer, because remember, once you run out of muscle glycogen, that you pretty much, we would say you hit the wall if you're running a marathon, or you bonk if you're mountain biking. You just can't go further once your muscle glycogen is depleted. You have to really cut way back. And so the more efficient you are as using fat for fuel, the more you can spare that muscle glycogen. As steady state exercise continues for a prolonged period of time, the percentage of energy derived from fat may increase slightly as the percentage of energy derived from carbohydrate oxidation declines. A question that sometimes comes up is, do you have to burn fat to lose body fat? Well, at lower intensity exercise, which we sometimes call the fat burning zone, respiratory exchange ratio will be lower than during high intensity exercise, with the exception of better trained athletes who can utilize fat for fuel at higher intensities. The percentage of energy derived from fat is high at low intensity exercise. However, the total amount of energy expended is lower. Therefore, it's not necessary to burn fat during exercise to lose body fat, because the total energy expended is more important than that percentage expended from fat. For example, if you exercise at a higher intensity, you're going to expend more total calories. And therefore, even though the percentage of calories expended from fat is a little bit lower, the total fat calories expended will be higher when your total energy expenditure is also higher. Some very beneficial general adaptations to endurance exercise are that fatty acids are more easily mobilized from adipocytes, or your fat cells, and the uptake of fatty acids into muscle cells is enhanced. In addition, the number and the size of mitochondria are increased, so you become much more efficient at using fat for fuel, both at rest and during exercise. So a major point with the last slide as well as this slide is that you don't have to exercise at a really low intensity to get these adaptations and to become more efficient at using fat for fuel at rest and during exercise. For those first starting out with exercise, it's good to exercise at a lower intensity, or you won't be able to go any length of time. You'll just peter out. But as you become better trained, it's good to vary that intensity and try to exercise more intensely. And that will increase these general adaptations to the endurance exercise. And you will become more efficient at using fat for fuel and spare that muscle glycogen. This slide is in regards to manipulating your diet in order to enhance fat metabolism. And although research is ongoing and often conflicting, endurance performance has been shown really not likely to improve on a really high-fat diet. Research shows high-fat diets can favor fat oxidation at rest and during light to moderate intensity activity or exercise. But when the carbohydrate availability is low, individuals just can't exercise that intensely. So the newer strategy is for a short-term carbohydrate restricted diet followed by carbohydrate restoration or the addition of carbohydrate prior to exercise and then during and after exercise. Caffeine is known as an ergogenic aid and can enhance performance. And one way it can do that is its effect on fat utilization. It may enhance fat mobilization, however, fat oxidation is not significantly increased. It is a central nervous system stimulant, and therefore it increases that sense of awareness and focus, and can also help with a decreased perceived effort in training and performance. And therefore, it's okay for an athlete to use it in moderation, but there's a caution to athletes not to abuse it and overconsume caffeine, because there are a lot of negative side effects such as increased heart rate and shakiness and those ups and downs that come with caffeine intake. So again, in moderation, it's okay as an ergogenic aid. A general guideline for daily fat intake is 1 gram per kilogram, and this is consistent with the acceptable macronutrient distribution range, so this should be AMDR, which is 20 to 35% of total caloric intake. In number 2, D is most correct, that increases in body weight are due to long-term excess energy consumption. And a long-term excess in any energy-containing compound can result in increased body weight or fat. And that includes if you have an excess of fat, carbohydrates, protein, and or alcohol in the diet. Individuals can adjust fat intake to achieve energy deficits as well as meet their training and performance goals. Reducing body fat can improve performance because fat weight is kind of dead weight. It's not really helping anybody in performance. And fat intake is typically reduced since reductions to carbohydrate or protein intakes can be detrimental to performance. Athletes may consume a short-term low-fat diet to achieve body composition goals, which is much more highly recommended than doing that long-term. Long-term can be detrimental to both the athlete's health and their performance. An example is given in your text of a bodybuilder, and this particular bodybuilder in the picture was a 220-pound bodybuilder who routinely consumes about 5,500 calories, which is 55 kilocalories per kilogram. His usual fat intake is about 1.5 grams per kilogram or 150 grams daily, or about 25% of total energy intake. So it's a little bit above that 1 gram per kilogram, but it's right within the acceptable macronutrient distribution range. And about 2 to 3 months before a big contest, he reduces his energy intake to approximately 3,500 kilocalories per day. So that's down about 2,000 calories per day. And that will help him to get that cut up look. In addition to reducing the calorie intake, he slightly increases his protein intake, slightly reduces his carbohydrate intake, and substantially reduces his fat intake. And his pre-contest fat intake is likely to be only about 65 grams daily or 0.65 grams per kilogram. So it's less than half of that recommended fat consumption. During the 7 days before the contest, he reduces his fat intake even more in an effort to lose as much body fat as possible without sacrificing muscle mass or the ability to maintain training. So that's why he doesn't decrease carbohydrate to really, really low, because he needs the energy to still train. After the contest, he will reduce his usual intake of 5,500 calories, which includes a routine fat intake of about 1.5 grams per kilogram per day. So if done correctly, a reduction in dietary fat intake can be a strategy that results in the safe loss of body fat. And some bodybuilders, they will decrease their carbohydrate intake substantially as well, and also sometimes even dehydrate a little bit to help get that real cut up look. The problems with inadequate fat intake on training performance and health include inadequate replenishment of the intramuscular fat cells, the inability to manufacture sex-related hormones. For example, if a woman athlete goes too low in body fat, and that's said to be anywhere from 10 to 12% body fat, their estrogen levels will decline and they can become amenorrheic, as well as that can also affect their bone density. And an inadequate fat intake as well as an inadequate calorie intake can lead to that too low of body fat, percentage body fat, and also lead to that inability to manufacture enough estrogen. And we call that the female athlete triad, which is the low body fat, as well as the lack of estrogen and the lower bone density that can occur. Another thing that can occur is a decline in your good type of cholesterol, or your high density lipoprotein, your HDL, as well as inadequate fat soluble vitamin intakes, because fat soluble vitamins are present typically with fat in foods and also are better absorbed when fat is present in the diet. Most athletes do not consume an appropriate amount of fat. Unsaturated fatty acids help to reduce heart disease, as well as they can help to decrease the risk for some types of cancer. And as mentioned, they're also more inflammatory, so they can increase chronic inflammation processes within the body. Trans and saturated fatty acids are associated with an increased risk for cardiovascular disease, so it's recommended to avoid excessive amounts of these types of fats. Food labels are required to show total fat, saturated fat, trans fat, and also cholesterol. Although cholesterol is not considered as much of a culprit in raising your LDL cholesterol as saturated fat and trans fat are. And we know that total fat, it can be healthy if it contains a lot of monounsaturated fat as well as omega-3 fatty acids. Monounsaturated and polyunsaturated fats appear on labels. However, this is voluntary. It's not a requirement. The Nutrition Facts Panel label helps people determine the amount and the type of fat in food, as well as the ingredient list. Here's the Nutrition Facts label, and it includes total fat, saturated fat, trans, as well as cholesterol. And over here is the percent daily value, and that's the percentage that this food would provide based on the amount that's allowed on a 2,000 calorie standard reference diet. And this is using the percent daily value is a really good way to compare labels. Let's say you were comparing two food products. Maybe they were frozen dinners. And this particular frozen dinner had 10% of the daily value of total fat and 9% of the daily value as saturated fat. And let's say a label over here had 20% of the daily value as saturated fat. So if you were trying to reduce saturated fat, you could go with this first product. And if a percent daily value is somewhere between 10 to 19% of the daily value, that's considered a good or significant source of that nutrient. If it's greater than 20%, that's considered high source of that nutrient. So for example, this particular food would be a high source of added sugars and a high source of calcium and a high source of iron. But it would be a significant source of vitamin D, as well as total fat, total carbohydrate, and fiber. It's a source of saturated fat, but it's not considered a significant source unless it would get over 10%, or a high source if it got over 20% of the daily value. And again, these percent daily values are based upon a standard 2,000 calorie reference diet. So if someone typically ate more than 2,000 calories, this percentage would relatively be lower for that individual. This table includes high-fat foods that also contain carbohydrate and protein. You can see an avocado, which is highly monounsaturated, has a significant amount of carbohydrate as well as some protein. Your nuts are good sources of plant protein, and they also have some carbohydrates, and they're also highly monounsaturated, or they include a significant amount of polyunsaturated. Walnuts having a significant amount of your omega-3 fatty acids, the alpha-linolenic acids. More high-fat foods that contain carbohydrate and protein, and I'm going to point out flax seeds. And when it's ground, you will get the benefits of the omega-3 fatty acids that are in the flax. And here it's a significant amount of carbohydrate, very high in fiber, and it's a healthy fiber. It promotes the health of colon cells, and it has a little bit of protein in there. Bacon is going to be, it has some monounsaturated, but it's going to be more highly saturated, as well as a Canadian bacon, coconut, and coconut milk. But remember, we talked about these saturated fatty acids as being shorter chain, which could possibly have a little bit of health benefits. But again, research is still a little bit conflicting. However, many people have adopted using coconut and coconut milk into smoothies and as part of their daily intake without seemingly a problem. Meat has approximately 7 grams in an ounce. So 3 ounces of all these different types of ground beef will have about 21 grams of protein. So they're consistent in protein, but they're going to vary in the amount of fat. And that would depend on how lean they are, as well as the tuna, whether it's in a tuna salad that has a lot of mayonnaise or tuna packed in oil versus just plain tuna in water, which will have much less fat. But they all will give you the omega-3 fatty acids. And the dark meat of it, like a chicken wing, is going to and will have more fat than a chicken breast. Just as there's about 7 grams per ounce of meat, there is about 8 grams of protein per cup or serving of milk or dairy. So all of these will have about the same amount of protein. However, they'll have varied amounts of fat. And up here you see the chicken breast too, which was much less than the chicken wing on the prior slide. And again, a non-fat or skim milk will have much less fat than a whole milk. The typical American diet is usually very high in fat and really too high for an athlete in training. There's often a high intake of red meat, processed meat, high-fat dairy, French fries, refined grains, sweets, and desserts, all containing not only a large amount of fat, but not very healthy fats. So what can an athlete do? They could reduce portion size of some of the higher fat foods. They could prepare the foods with less fat, such as baking versus frying. Adding less fat to foods if it calls for so much butter or oil, reduce that amount, or use healthier oils. Order carefully at restaurants. Be aware of hidden fats. Lower fat cuts of meat or poultry could be used, and lower fat or non-fat dairy products, and lower fat versions of high-fat processed foods, or try to eliminate those processed foods altogether. The more whole foods, the better. And then substitute fruits and vegetables for those higher fat and high sugar containing snack foods. And how many of you like these high-fat coffee drinks? Sometimes they're good and they can be used in moderation, but they are expensive and there are a lot healthier choices. There's so many healthy ways to make smoothies. Using different protein powders as well as adding fruits and vegetables. You'll save money and be much healthier, and it will enhance performance. Your book has an excellent section on fat-related dietary supplements or ergogenic aids, so go ahead and read that on your own, which includes fat-burning or supposedly fat-burning supplements, caffeine, which we've discussed a little bit, supplements like carnitine, medium-chain triglycerides, and omega-3 fatty acids. In summary, fat is the most energy-dense nutrient found in food. Remember, 9 kilocalories per gram, and it metabolizes to make about 129 ATP versus the 36 to 38 that carbohydrate will make. The predominant fat in food and in the body is triglyceride. Fat absorption, digestion, transportation, and metabolism are slow and also complicated, much more so than glucose. The main sites for fat storage are adipocytes, which are your fat cells, liver, and muscle cells. Fat is a primary energy source at rest and during low intensity activity. But remember that the more well-trained an individual is, the more efficient they are at using fat for fuel at higher intensities. Athletes find that their diets tend to be relatively lower in fat than the typical American diet, which is good. And also, they want to focus on the healthier types of fat. And remember that the general recommendation was about 1 gram per kilogram. But first and foremost, it's important that they meet their protein and their carbohydrate needs. Caution should be used when restricting fat because athletes can reduce the fat in their diets too much, and that can hinder both their health and their performance.